Imagine a newborn baby who literally forgets to breathe.
Right.
And not because their lungs are underdeveloped or, because of a traumatic birth.
No, not at all.
They forget to breathe simply because a single microscopic letter is missing from a genetic sequence of over 3 billion letters.
It's hard to even wrap your mind around.
It really is. Today, we're doing a deep dive into PURA syndrome.
And it's a condition that, well, it perfectly illustrates how precariously balanced human biology really is.
Yeah, exactly.
Because a microscopic omission creates this global systemic shockwave throughout the entire body.
And we know exactly who is listening today. You might be a parent or a caregiver who has just received this diagnosis for your child.
And the dust is probably still settling. The shock is very much still there.
Right, and you're facing what is arguably one of the most exhausting hurdles of this entire process, making those first phone calls to your family and friends.
Oh, sharing the news takes just an immense toll.
It does.
You're trying to process your own grief and confusion, and suddenly you are expected to be the chief medical educator for everyone you know.
Exactly. It's so draining. And while we aren't here to give you, psychological advice or write a literal script for setting emotional boundaries.
Right, that's not our lane.
No, but we are going to give you something just as vital. We're going to give you the ultimate foundational understanding of this condition.
We're going to translate all that dense, intimidating medical literature into a crystal clear map.
Yes, the science, the symptoms, and the future. Because once you truly understand the why and the how behind what is happening in your child's body, you don't have to keep repeating the same confusing, painful details.
Exactly. You gain the confidence to steer the narrative. You become the expert in the room.
So by the end of this deep dive, you will be equipped to explain PURA syndrome to a grandparent, a teacher, or even a new doctor with total clarity.
That's the goal.
We're going to start from the moment this condition was first discovered just over a decade ago. Then we'll unpack the microscopic mechanics of the PURA gene, walk through the lifelong clinical reality starting from day one in the NICU, and finally, look at the incredibly hopeful research pipeline happening right now in March 2026.
Because the transition from a complete medical mystery to a highly specific molecular target in just over 10 years, it's staggering.
It really is.
It's one of the most rapid scientific evolutions in modern rare disease research.
So let's start right there, the origin story. Because if you look back just prior to 2014, PURA syndrome as a name, as a diagnosis, it didn't exist.
It completely didn't. Prior to October 2014, a family dealing with these severe symptoms, the profound low muscle tone, the seizures, the developmental delays, they would never hear the word PURA.
But doctors weren't totally in the dark, right? They had a different, much clunkier name for what was going on.
They did. Geneticists were diagnosing a subset of these children with something called 5q31.3 microdeletion syndrome.
Okay, let's break down 5q31.3 for everyone.
Sure. So, we all know our DNA is organized into chromosomes. The 5 refers to chromosome 5. The Q refers to the long arm of that chromosome, and 31.3 is the exact address on that arm.
Got it.
Clinicians were using genetic arrays to look at the architecture of the DNA, and they could see that some patients were missing a tiny chunk of genetic material at that exact address.
A microdeletion.
Exactly, a microdeletion.
But a microdeletion isn't just one single gene, is it?
No, and that was the core of the mystery. A microdeletion can encompass several genes all at once.
Okay.
So if your genome is an encyclopedia, a microdeletion is like tearing an entire page out. You lose several different paragraphs of instructions.
Oh, that makes sense. So the doctors knew the page was missing, and they knew the patients missing that page had devastating neurological issues.
Right, but they didn't know which specific paragraph on that torn-out page was actually responsible for the symptoms.
It's like knowing there's a massive power outage in a city block. You know the whole block is completely dark. But in 2014, scientists finally realized that it wasn't the whole block failing that caused the specific issues. It was a single, specific blown fuse within that block.
Yes.
And that fuse was the PURA gene.
Right. In late 2014, 2 independent research teams made this exact breakthrough simultaneously.
Oh, wow.
Yeah, Dr. David Hunt's team in the UK and Dr. Seema Lalani's team in the US.
What did they find?
Well, they looked at a cohort of patients who didn't have the whole microdeletion. They didn't have the whole city block out.
Okay.
Instead, they had tiny pinpoint mutations solely within the PURA gene itself.
So the rest of the page was completely intact.
Exactly.
Only that one paragraph had a typo.
Precisely. And the revelation was that these patients with just that single typo exhibited the exact same core symptoms as the patients missing the whole chunk.
That's huge.
It definitively proved that disrupting the PURA gene alone was sufficient to cause the profound hypotonia, the neonatal breathing issues, and the neurodevelopmental delay.
And that was the birth of TRA syndrome.
That was it.
Now, the original papers in 2014 described just 15 cases, but the clinical landscape looks vastly different today.
Oh, absolutely.
Because by late 2024, the global number of confirmed cases skyrocketed to around 706, spread across 60 different countries.
Yeah, and we have to be clear about why that explosion in numbers happened. The disease didn't suddenly become contagious.
Right, right.
Our diagnostic technology simply caught up.
You're talking about whole exome and whole genome sequencing?
Yes, exactly. Before sequencing became widely accessible and financially viable, you could only find a genetic error if you knew exactly where to look.
Or if the error was massive, like that microdeletion we talked about.
Exactly. But whole exome sequencing allows a machine to read the patient's DNA letter by letter.
Wow.
It flags those tiny singular typos in the PURA gene that older arrays completely missed.
But even with that technological leap, I mean, an incidence of roughly 1 in a million makes this an ultra-rare disease.
It does.
Which tells me there is a silent population out there.
Oh, undoubtedly.
There have to be older adults or children in countries without access to advanced genetic testing who are sitting in wheelchairs right now, misdiagnosed with generic cerebral palsy or unspecified severe autism,
Yes.
who actually have PURA syndrome.
Without a doubt. And this touches on what clinical geneticists call the Diagnostic Odyssey.
A Diagnostic Odyssey.
It's the agonizing, often years-long gauntlet that families endure.
Yeah.
You bounce from neurologist to endocrinologist to physical therapist. You subject your child to muscle biopsies, lumbar punctures, endless MRIs.
All just trying to answer the question, what is happening to my child?
Exactly.
And when the phone finally rings and a genetic counselor says, we found it, it's a mutation in the PURA gene, I can only imagine the emotional whiplash.
It is the ultimate double-edged sword. You are receiving definitive confirmation of a severe, life-altering, lifelong disability.
Yeah.
That is devastating. But simultaneously, the audit ends. You have a name for the condition.
You can stop the invasive, pointless testing.
Yes. And crucially, you can find your community. You transition from being an isolated medical anomaly to being part of a global family of over 700 other people who implicitly understand your daily life.
That shifts the ground beneath your feet.
It really does.
When you are making those first calls to your siblings or your parents, being able to say the words PURA syndrome moves the situation from a terrifying, nebulous mystery to a concrete biological reality.
Right.
But to really empower you to explain that reality, we have to look closely at what that blown fuse actually does inside the body.
We need to go microscopic.
Let's unzip the genes.
The PURA gene has a very unusual architecture,
Yeah.
which is key to understanding why mutations are so catastrophic.
Okay.
It's classified as a single exon gene.
We hear the terms exon and intron thrown around a lot in genetics. Let's define them clearly in this context.
Sure, so think of a standard gene as a television broadcast. The actual show you want to watch, the vital information, is broken up into segments.
Okay, the segments of the show.
Right. Those segments are the exons. But between those segments, you have commercial breaks. Those are the introns.
Non-coding sections of DNA.
Correct. When a typical cell reads a gene to build a protein, it goes through a process called splicing.
What's slicing do?
It essentially records the broadcast, edits out all the commercial breaks, the introns, and splices the exons together to create a single, cohesive instruction manual.
But the PURA gene doesn't work that way.
No. The PURA gene has no introns.
Wait, really?
None. It has no commercial breaks. It is a single, unbroken, continuous sequence of coding DNA. One single exon.
Wow. Why does that structural difference make it so vulnerable?
Because it completely removed the margin for error.
How so?
In a standard gene, if a random genetic mutation happens to land inside an intron or commercial break, the cell just edits it out during the splicing process.
Oh, I see.
The final protein is perfectly fine. The commercial break took the hit.
But with a single exon gene.
Every single nucleotide letter is part of the final broadcast. There is nowhere for a typo to hide. Any mutation, anywhere in the sequence, is almost guaranteed to alter the final product.
And that final product is a protein called Pur-alpha.
Yes.
The sources describe this protein as highly conserved.
Highly conserved is a term evolutionary biologists use when they see the exact same protein structure across vastly different species.
Like from humans to mice to fish.
Exactly. When nature refuses to tinker with a protein over millions of years of evolution, it tells you that the protein is absolutely non-negotiable for life.
Wow.
If it changes, the organism usually doesn't survive.
So Pur-alpha is essential, but what is it actually doing?
It's a master regulator, a molecular multitool.
Okay.
It regulates DNA replication, ensuring the genome is copied correctly when cells divide. It regulates gene transcription, meaning it helps turn other genes on and off.
Right.
But its most critical function, the one that really explains the neurodevelopmental devastation of PURA syndrome, is mRNA transport.
Okay, wait. I'm stuck on mRNA transport. If the DNA is safely housed inside the nucleus of the cell, why does the cell need to transport mRNA anywhere?
That's a great question.
Can't the main cell body just build the protein and ship the finished product to wherever it's needed?
In most cells, yes, that works perfectly fine.
Yeah.
But neurons' brain cells are uniquely structured.
Oh, so?
A neuron has a main body, but it also has these incredibly long branching arms called dendrites.
Oh, right.
Those dendrites reach out to connect with other neurons, forming synapses. When a child learns to walk or swallow or recognize a face, those synaptic connections have to physically change and strengthen.
And that is called synaptic plasticity.
Exactly. And to strengthen a synapse, you need new proteins.
Okay.
But the dendrites are so long that if the synapse had to wait for the main cell body to build a finished protein and ship it all the way down the arm,
It would take too long.
way too slow. The brain couldn't learn in real time. So the neuron has a workaround.
What's the workaround?
Instead of shipping the finished protein, it ships the blueprint for the protein down to the synapse, so the synapse can build it locally on demand.
Oh, that makes sense. The blueprint is the messenger RNA, the mRNA.
Yes, but mRNA is fragile. It can't just float down the dendrite on its own. It needs to be carefully packaged, protected, and physically carried to the construction site at the synapse.
Enter the delivery driver, the Pur-alpha protein.
Precisely. Pur-alpha binds to the mRNA blueprints, carries them down the dendrite, and facilitates the local synthesis of proteins right where they are needed to build new neural pathways.
So if we follow this analogy, does a mutation in the PURA gene mean the delivery truck engine blows out? Or does it mean the driver just gets lost and delivers the blueprints to the wrong cell?
It's actually more anatomical than that.
Oh.
To understand the malfunction, you have to look at the shape of the Pur-alpha protein. It has 3 specific sections called Pur repeats. Repeat 1, repeat 2, and repeat 3.
Okay.
Think of these repeats as the physical hands of the delivery driver.
Hands designed to grip the mRNA.
Exactly. These hands are molecularly designed to grip very specific patterns of genetic letters called GGN motifs.
GGN motifs, okay?
If we look at one of the most common mutational hotspots in PURA syndrome, a variant called P233del.
Let's translate P233del.
It means that at position 233 in the protein's chain of amino acids, a single amino acid called phenylalanine, or Phe, has been deleted.
Just one tiny building block missing out of 322.
Yes, but that specific deletion happens right in the middle of Pur repeat 3, one of the hands.
And deleting one amino acid destroys the whole hand.
It does, because it destroys what's called the beta sheet structure.
The beta sheet.
Proteins aren't just floppy strings, They fold into very precise 3D origami shapes. A beta sheet is a structural formation where sections of the protein chain line up parallel to each other, creating a rigid surface.
Oh, so it's literally the palm of the hand.
Yes. When you delete that one phenylalanine, the beta sheet collapses. The structural integrity is gone. The hand is mangled.
So the delivery driver is still there, but their hands are crushed. They cannot grip the GGN motifs. They cannot pick up the mRNA blueprints.
And if they can't pick up the blueprints, the materials never arrive at the synapse.
The brain's construction sites sit empty.
Exactly. The neural pathways required for muscle tone, for breathing, for speech, they simply cannot be built.
When you are on the phone with your family trying to distill this dense genetics lesson, you can use that.
Absolutely.
You can say, look, the brain is constantly trying to build new connections, but because of a single missing letter in the DNA, the cellular delivery system that brings the building blueprints to the construction sites is broken. The materials never arrive.
It is a scientifically pristine way to explain it to a layperson.
It paints such a clear picture.
Now, it's important to clarify that the patient doesn't have zero functional Pur-alpha. They have a condition called haploinsufficiency.
Let's unpack that. We all inherit 2 copies of every gene, one from our mother and one from our father.
Correct. In PURA syndrome, 1 copy of the PURA gene is completely normal. It is producing perfectly healthy Pur-alpha delivery drivers. But the other copy has the mutation, producing the broken drivers.
So they have half the workforce.
Exactly. Haploinsufficiency means that having only 50% of the normal workforce is insufficient for the brain to develop properly.
The healthy half just cannot keep up with the massive physiological demand.
They simply can't.
There's a critical point about inheritance here that parents really need to hear loud and clear. Almost all pathogenic variants in PURA are de novo.
De novo translates to new. These mutations are spontaneous.
Spontaneous.
They occur randomly during the formation of the specific sperm or egg that created the child, or very shortly after conception.
Right.
They are not inherited from the parents. The parents' genetic blood tests will show perfectly normal PURA genes.
Which means, and I want to say this directly to any parent listening who is currently spiraling in guilt, this is not something you pass down.
It is not your fault.
It wasn't the glass of wine you had before you knew you were pregnant. It wasn't the stress at work. It wasn't the deli meat. It was a completely random, spontaneous biological typo that no one could have predicted or prevented.
The clinical relief parents feel when they hear that is profound. It absolves them of a completely misplaced burden.
I can only imagine.
And because it's a spontaneous typo, the risk of it happening again in a future pregnancy is exceedingly low. Just the baseline risk for the general population.
Though genetic counselors will often mention something called gonadal mosaicism.
They will.
Just so parents aren't blindsided by the term, what does that mean?
It is an exceptionally rare scenario where a parent's blood tests negative for the mutation, but a small, isolated cluster of their reproductive cells, their tests or ovaries, actually carries the mutation.
Oh, I see.
Because those cells are hidden away, the blood test misses it. So there is a tiny fractional residual risk for future pregnancies.
Which is why genetic counseling is always standard practice.
Always. But practically speaking, the recurrence risk is usually cited as less than 1%.
Okay, so we have a fetal brain trying to wire itself in the womb with only half the required delivery drivers.
Right. When those cellular construction sites lack materials, the effects aren't delayed until childhood. They are immediately, terrifyingly visible the absolute second the child is born.
Yes.
Let's transition to day 1, the neonatal crisis.
The clinical presentation in the delivery room or the NICU is acute.
Very acute.
Neonatologists are confronted with a highly specific triad of symptoms that define the early days of PURA syndrome.
The triad. We are talking about severe hypotonia, respiratory insufficiency, and profound feeding difficulties.
Let's take them one by one.
Let's start with hypotonia, which is universally present, affecting over 95% of infants.
Hypotonia is extremely low muscle tone. Doctors will often use the term floppy baby syndrome.
Yeah.
The infant feels heavy and limp, unable to maintain any posture or move their limbs against gravity.
It's terrifying for a parent to hold a baby that lacks that natural, springy resistance.
Absolutely terrifying. But low muscle tone can be caused by a lot of things. How does a neurologist look at a floppy baby and start pointing the compass toward a central brain issue like PURA rather than a muscle disease?
Through a deceptively simple clinical exam checking the deep tendon reflexes.
Like tapping the knee with a rubber hammer.
Exactly. When you have a peripheral neuromuscular disorder like spinal muscular atrophy or SMA, the actual lower motor nerves that physically connect to the muscles are dying.
The wiring is cut.
Yes, the wiring is cut. So when you cap the knee, nothing happens. The reflex is absent.
Right.
But in PURA syndrome, the problem isn't in the peripheral wiring. The problem is in the brain, the upper motor neurons.
So the wiring to the muscles is perfectly intact, but the main command center in the brain just isn't sending the baseline signal to stay tense.
Right, because the wiring is intact when the doctor taps the knee, the deep tendon reflex is preserved.
Wow.
It's often perfectly normal or even hyperactive.
That preserved reflex is a massive clinical clue that the hypotonia is central in origin, guiding the diagnostic testing away from muscle biopsies and toward brain imaging and genetics.
It changes the whole diagnostic path.
Now, the second pillar of the neonatal triad is respiratory insufficiency. Over 50% of these infants experience recurrent apneas, which means they simply stop breathing.
And in PURA syndrome, you're dealing with two distinct types of apnea simultaneously.
Okay, what's the first one?
First, you have central apnea. This points directly back to the brainstem. The brainstem controls our autonomic functions.
Right.
Because the Pur-alpha protein deficiency is so severe there, the brainstem literally forgets to generate the rhythmic electrical drive to breathe.
The signal just drops out.
Yes. And then, complicating matters, you have obstructive sleep apnea.
That's a mechanical failure.
Exactly. The severe hypotonia we just discussed doesn't only affect the arms and legs. It affects the muscles of the airway and throat.
Oh, of course.
When the baby relaxes into sleep, those floppy tissues cave in under gravity and physically block the airway.
So you have a brain that forgets to send the breathe signal and an airway that collapses even if the signal does get through.
That's a dual failure.
It explains why so many of these infants require mechanical ventilation, CPAP machines, or supplemental oxygen in the NICU.
It does. But clinically, we do see a very specific hopeful trajectory regarding the breathing.
Oh.
The central respiratory drive issues often slowly improve and sometimes resolve entirely as the child passes their first birthday.
That's amazing.
The brainstem seems to mature just enough to take over the baseline autonomous rhythm, though many children will require sleep apnea monitors at night for years.
The third part of the triad, and often the most persistent daily grind for caregivers, is feeding difficulties. Over 80% of these babies have dysphagia.
Dysphagia is impaired swallowing.
Right.
Swallowing feels simple to us, but neurologically, it is an astoundingly complex reflex.
I don't think we realize how much is involved.
It requires the precise, split-second coordination of multiple cranial nerves and dozens of tiny muscles in the jaw, tongue, pharynx, and esophagus.
Wow.
You have to coordinate the suck, trigger the swallow, and simultaneously close the epiglottis over the windpipe so you don't inhale the liquid.
But with severe central hypotonia, that split-second choreography is impossible.
The muscles are too sluggish, the timing is off. If they try to take a bottle, the milk bypasses the sluggish epiglottis and goes straight down the trachea into the lungs.
Which causes aspiration pneumonia, a life-threatening infection.
Yes. To prevent that, these babies almost universally require a nasogastric tube, an NG tube threaded through the nose, down the esophagus, and into the stomach for entirely passive feeding.
And because the swallowing dysfunction rarely resolves quickly, the clinical protocols strongly recommend transitioning to a gastrostomy tube, a G tube, which is surgically implanted directly through the abdomen into the stomach.
Right. It ensures the child gets the vital calories they need to grow without the constant risk of aspiration.
Aside from the triad, the NICU nurses will note a slew of other symptoms that paint a picture of total autonomic dysregulation.
The brainstem just isn't regulating the body's background systems.
Hypersomnolence is a big one.
Extreme excessive sleepiness.
Yeah.
It goes beyond a tired newborn. These babies are profoundly lethargic, making it nearly impossible to rouse them for therapies or attempted feedings.
They also suffer from hypothermia. Their central thermostat is broken, so they cannot regulate their own body heat.
Right.
And there's a really specific, almost heartbreaking detail noted in the advocacy sources about hiccups.
Yes. Many mothers, in retrospect, report feeling their babies hiccuping constantly and violently in utero.
That's wild.
And those intractable hiccups continue into early infancy.
Because a hiccup is controlled by the brainstem.
Exactly. A hiccup is a spasmodic contraction of the diaphragm, controlled by the brainstem. It's a subtle early red flag that the autonomic circuitry is misfiring.
Since we are talking about the NICU and the frequent need for procedures like placing that G-tube, we have to pause and talk about anesthesia.
We must.
This is perhaps the most critical, life-saving piece of practical information in this entire deep dive.
If a child with PURA syndrome needs surgery, standard pediatric anesthesia protocols are incredibly dangerous.
The clinical guidelines are shouting this from the rooftops.
They are.
Because their brainstem is already struggling to maintain a respiratory drive, they have an extreme sensitivity to respiratory depressant drugs, particularly opioids.
The central nervous system just cannot handle the suppression.
The guidelines explicitly recommend minimizing the use of opioids by at least 50% compared to a typical child of the same weight.
That's a massive reduction.
Furthermore, because of their autonomic inability to regulate temperature, they have a massive risk of severe hypothermia while under general anesthesia.
The surgical team must use active thermoregulation warming blankets, heated 5E fluids in the operating room.
And the danger doesn't end when they wake up.
No, it doesn't.
The risk of delayed postoperative apnea, meaning they suddenly stop breathing hours after the surgery, is incredibly high.
They mandate 24-hour post-operative inpatient monitoring with continuous pulse oximetry. They cannot be sent home to recover the same day.
I want to hammer this home for the parents.
Please do.
When you are sitting in the pre-op room, you cannot assume the anesthesiologist knows about PURA syndrome.
Never assume.
You must advocate. You must hand them the clinical guidelines and say, my child has a uniquely vulnerable central nervous system. They need opioid reduction, active warming, and an overnight stay.
It is not being difficult. It is keeping your child alive.
It is the absolute essence of parent advocacy.
Truly.
As the child eventually stabilizes and graduates from the NICU, the acute medical terror begins to subside.
The apneas might lessen.
Right. But a new reality sets in. As they enter childhood, the long-term neurodevelopmental profile of PURA syndrome takes over.
And the first thing clinicians must establish, which brings a wave of profound relief to terrified parents, is the classification of the disorder.
Yeah, this is so important to explain to family.
PURA syndrome is a neurodevelopmental disorder. It is not a neurodegenerative disorder.
Explain why that distinction matters so much.
A neurodegenerative condition like Tay-Sachs or certain types of Batten disease is one where a child might develop normally for the first year or two, but then the brain tissue actively begins to die.
That's horrifying.
They lose the skills they acquired, they regress, they forget how to walk, how to speak, how to swallow. It is a relentless downward trajectory.
But PURA doesn't do that.
No, PURA is neurodevelopmental. The brain's architecture is delayed and structurally compromised from the very beginning because of the missing Pur-alpha protein.
Right.
But the tissue itself is not actively decaying. Individuals with PURA make slow, incremental progress. They move forward.
And crucially, barring a massive epileptic event, they do not lose the skills they fight so hard to acquire.
They hold on to their victories.
But the gap between their development and a neurotypical peer's development is vast, and it widens over time.
It does. The intellectual disability ranges from moderate to profound.
And the motor delays are severe.
Motor milestones are a long, arduous climb. Independent walking is often never achieved.
Many individuals will use custom wheelchairs for life.
Yes. For those who do achieve independent walking, it is delayed significantly, typically occurring anywhere between 3 and 10 years of age.
And the gait is distinct.
Yes, because the baseline hypotonia never fully resolves, they walk with a wide-based, unsteady gait.
Okay.
They lack the core stability to balance easily, making them highly prone to falls. It requires years of intensive, lifelong physical and occupational therapy to build and maintain that mobility.
But where the daily reality of PURA syndrome really crystallizes is in communication.
This is a big one.
This is what I call the mind-body disconnect. The vast majority of individuals with PURA are completely non-speaking or non-verbal. They cannot articulate meaningful spoken words.
The neurological circuitry required to coordinate the breath, the vocal cords, the tongue, and the lips simultaneously. It is simply too complex a motor plan for their compromised system to execute.
But, and this is the most poignant, vital characteristic of this syndrome, there is a massive documented discrepancy between their receptive language and their expressive language.
This is what families need to tell everyone they meet. Receptive language is what the brain understands. Expressive language is what the body can output.
Exactly.
In PURA syndrome, the receptive comprehension is leaps and bounds ahead of the expressive ability.
Parents, therapists, and neurologists constantly note that these children are highly social, deeply affectionate, and incredibly observant.
They understand what is happening around them.
Completely. They follow complex commands, they understand jokes, they recognize people, they have distinct preferences and vibrant personalities.
The cognitive lights are on.
They are trapped by a motor inability to speak, not a cognitive inability to comprehend.
It's like having a brilliant, state-of-the-art computer operating system running perfectly in the background.
Yeah.
It's doing the calculations, processing the data, but the physical keyboard and monitor are unplugged.
Oh, wow.
The machine has no way to output the data to the user.
That is a phenomenal analogy. When you're making those phone calls, it's just exhausting to explain why they aren't talking, but they are understanding. That computer analogy is perfect.
And if the keyboard is unplugged, you don't just give up on the computer.
No, you find a different output device. You find an adapter cable.
In the clinical world, that adapter cable is augmentative and alternative communication, ACC.
The sources stress that early introduction of AAC is not just helpful, it is psychologically critical.
It changes everything. AAC isn't a single device. It's a spectrum tailored to the child's specific motor capabilities.
What does that look like?
For some, it might be low-tech manual signing. Often, therapists use simplified systems like keyword sign.
Where you only sign the most important word in a sentence.
Right, because their fine motor skills can't handle complex ASL.
Or symbol-based communication boards where they can physically point to what they want.
Yes. But for those with the most severe hypotonia, where they lack the fine motor control to even point a finger reliably, we turn to high-tech AAC.
Eye gaze technology.
Exact.
How does eye gaze actually work for a child with severe motor delays?
If the child's visual tracking is intact, meaning they can intentionally move their eyes to follow an object, therapists can mount a specialized infrared camera to a tablet on their wheelchair.
Okay.
The camera tracks the reflection of light on the child's pupils. The child simply stares at a specific icon on the screen, say a picture of a cup or a picture of their mom for a preset amount of time called the dwell time.
Oh, I see.
The machine reads the gaze as a mouse click, and the tablet speaks the word out loud.
It literally gives them a voice. It bridges the mind-body disconnect.
And it is vital to understand that AEC isn't just about basic needs.
Right. It's not just so they can say, I'm hungry or I hurt.
No, it is about social agency. It allows them to tease their sibling, to express an opinion, to participate in the emotional life of the family.
Imagine the alternative. Imagine living for 10 years, understanding everything around you, having a complex internal life, and never being able to communicate a single thought.
The sheer psychological torture of that.
It breeds intense frustration. When you see behavioral issues in nonverbal children, aggression, screaming, self-injury, it is almost always rooted in communication failure.
The energy of that trap thought has to go somewhere. Giving them AAC early prevents that frustration from calcifying into severe behavioral problems.
As families are working tirelessly to bridge this communication gap, they often hit a new, terrifying wall.
Yes.
As the child transitions from infancy to toddlerhood, the neurological landscape shifts. Let's talk about the neurological storms.
Between the ages of 2 and 5, the neurological burden of PRA syndrome frequently escalates with the onset of epilepsy and various movement disorders.
Epilepsy affects more than 50% of the PRA population.
It does.
But it doesn't usually start as the dramatic, full-body seizures we see in movies.
No, the seizure profile is complex and evolutionary. It frequently begins subtly with myoclonic jerks.
What are those?
These are brief, sudden, involuntary muscle twitches. They might look like a child suddenly dropping their head or their arm jerking upward.
But over time, those electrical storms in the brain grow more organized and more destructive.
They often progress into generalized tonic-clonic seizures, what we used to call grand mal seizures, involving violent convulsions and a total loss of consciousness.
And in some of the most severe cases, the epilepsy evolves into an epileptic encephalopathy known as Lennox-Gastaut syndrome.
Lennox-Gastaut is a devastating diagnosis on its own.
It is. Lennox-Gastaut is characterized by multiple different types of seizures occurring continuously throughout the day.
Crucially, it involves drop attacks, where all muscle tone suddenly vanishes and the child violently collapses to the floor, requiring them to wear protective helmets constantly.
And it is notoriously difficult to control, and the constant electrical seizing disrupts whatever cognitive progress the child is making.
Right.
Why is the epilepsy in PURA so hard to control? The clinical literature repeatedly uses the word refractory, meaning drug-resistant.
It comes down to the origin of the seizures. Sometimes epilepsy is focal. It's caused by a tiny malformation or scar tissue in one specific lobe of the brain.
Okay.
A neurosurgeon can physically go in, cut out that tiny piece of tissue, a focal resection, and functionally cure the epilepsy.
But in PURA syndrome, the defect isn't focal.
Exactly. Every single neuron in the entire brain is operating with only half of its required Pur-alpha protein. The defect is global. You cannot resect it.
So management relies on an agonizing trial and error process of polypharmacy stacking multiple heavy anti-seizure medications together.
Trying to find a cocktail that dampens the electricity without completely sedating the child.
Or using implanted devices like a vagus nerve stimulator, a VNS, which acts like a pacemaker for the brain, sending regular electrical impulses up the neck to disrupt seizure activity.
But here is where the diagnostic waters get incredibly treacherous, and why parents must insist on seeing a specialized pediatric epileptologist.
This is so important.
Not every abnormal movement you see in a child with PURA is a seizure.
This is a massive distinction. Patients exhibit non-epileptic movement disorders alongside the epilepsy. They have dystonia.
Dystonia involves sustained, involuntary muscle contractions that cause repetitive movements, or abnormal twisting postures. It can be incredibly painful.
They also exhibit stereotype as repetitive rhythmic movements like hand flapping or hand biting, often used for self-soothing or sensory regulation.
But the most deceptive movement is what the sources call a pathological startle response, or hyperacusis.
This is flagged as a major diagnostic red flag. Explain what this looks like.
We all have a startle response. If a door slams, you jump.
Right.
But in PURA, the central nervous system is hypersensitive and lacks the ability to filter sensory input. So a pathological startle response is an exaggerated, violent, and prolonged physical reaction to a seemingly minor stimulus. A dog barking, a sudden shadow, or even a light touch can cause the child to violently jerk their entire body.
If a parent or an ER doctor who isn't familiar with PURA sees a child violently jerk their entire body, what are they going to think?
They're going to think, that is a myoclonic seizure, the epilepsy is getting worse.
And what happens if you treat a startle response like a seizure?
You make a catastrophic management error.
Wow.
If you misdiagnose a startle as a seizure, the reflex is to increase the dosage of their anti-seizure medications.
But those medications work by globally suppressing brain activity.
Exactly. They do absolutely nothing to fix a sensory processing startle response. All you achieve is unnecessarily sedating an already delayed child, turning them into a zombie while the startle response continues.
This is why clinical guidelines mandate continuous video EEG monitoring.
You have to put the electrodes on their scalp, record the brain waves, and have a camera on them.
When the child jerks, you look at the EEG. If there is an electrical storm on the monitor, it's a seizure. If the brainwaves are flat and normal during the jerk, it's a startle response.
You must separate the electrical from the behavioral, or you will over-medicate the child.
Speaking of treatments for refractory cases, I want to dive into a fascinating case study detailed in the sources. A 2024 paper by Pur-alpha and colleagues documented an 11-year-old boy with a specific frame-shift PURA mutation.
A frame-shift mutation is essentially a typo that shifts the reading frame of the entire genetic code, usually resulting in a severely truncated, utterly useless protein.
This boy was suffering from up to 30 severe flexion spasms a day. He failed on high doses of valproate because the side effects were too toxic.
And levetiracetam didn't touch the seizures.
Out of options, his doctors put him on the ketogenic diet.
The ketogenic diet, or keto, has been co-opted by the wellness industry, but it was actually developed in the 1920s specifically as a strict medical therapy for intractable childhood epilepsy.
How does eating fat stop a seizure?
Normally, the brain runs on glucose from carbohydrates. When you drastically restrict carbs and increase fats, the liver converts fat into ketone bodies. The brain is forced to switch its primary fuel source to ketones. This metabolic shift alters the concentration of neurotransmitters in the brain.
Interesting.
Specifically, it increases GABA, which calms the brain, and decreases glutamate, which excites the brain. It fundamentally lowers the electrical excitability of the cortex.
And for this 11-year-old boy, it worked. The spasms were reduced. But the 2024 paper highlighted a completely unexpected secondary breakthrough.
This was wild.
For the very first time in the medical literature, they documented that the keto diet also massively improved his severe sialorrhea.
Sialorrhea is excessive drooling. And while it sounds minor compared to seizures, it is actually a devastating quality of life issue.
Because of the profound facial hypotonia and swallowing dysfunction, these patients cannot manage their own saliva. They constantly drool.
Which leads to chronic skin breakdown of the chin and neck, constant clothing changes, hygiene issues, and terrible social stigma as they get older.
Exactly. Normally, neurologists treat sialorrhea with anticholinergic drugs or Botox injections into the salivary glands.
But here, simply changing the metabolic fuel of the brain from glucose to ketones somehow improved this autonomic muscular coordination issue.
Do the researchers know why?
They admit they don't fully understand the precise mechanism yet.
Wow.
It could be the ketones improve the overall efficiency of the remaining Pur-alpha protein, or it could be a secondary effect of reducing the subclinical electrical static in the brainstem, allowing the swallowing reflex to fire more cleanly.
Whatever the mechanism, it's a brilliant observation that opens up an entirely new avenue for managing these complex symptoms holistically.
You aren't just piling on more sedating pharmaceuticals.
Yes.
You are altering the metabolic environment.
And that holistic view brings us perfectly into the next phase of our deep dive, the whole body impact.
Because Pur-alpha is expressed ubiquitously, meaning it is essential in almost all human tissues, not just the brain, You cannot manage PURA syndrome by only looking at the neurology.
You have to manage the entire biological system, and you have to plan for decades.
You do.
Let's start with the skeletal system. We've talked constantly about hypotonia. When a child has low muscle tone, they aren't walking, running, or bearing weight normally.
And bone is living tissue. It requires the dynamic vertical stress of gravity and the mechanical pulling of strong muscles to grow dense and straight.
Without that muscular scaffolding, the skeleton warps under the uneven stress.
The sources state that nearly half the PURA population, about 48%, developed severe scoliosis, a lateral curvature of the spine.
Clinically, we see that the spinal curve is aggressive and progressive.
If it is ignored, the spine will eventually curve so dramatically that it compresses the rib cage, crushing the lungs and fatally compromising their already fragile respiratory system.
It also makes sitting in a customized wheelchair agonizingly painful.
Which is why they require heavy, restrictive plastic torso braces to try and delay the curve. And eventually, many require massive spinal fusion surgeries, where orthopedic surgeons use titanium rods to physically bolt the spine straight.
They also face a high risk of hip dysplasia, where the weak muscles allow the hip socket to shallow out until the femur simply dislocates.
It's just constant monitoring.
But beneath the structural warping, there is a hidden chemical danger to the bone's osteopenia, or dangerously low bone mineral density.
Part of this is simply the lack of weight bearing, but a massive contributing factor is the epilepsy medication.
How do seizure meds damage bone?
Many classic anti-seizure drugs, particularly enzyme-inducing ones, speed up the liver's metabolism. Specifically the cytochrome P450 enzymes.
Okay.
They chew through the body's stores of vitamin D far too quickly. Vitamin D is essential for absorbing calcium.
Oh, I see.
So the medications chemically leach calcium out of the bones, making them brittle and porous.
This leads to pathological fractures.
Yes, a bone breaking not from a fall, but from the simple daily act of a caregiver rolling the child over to change a diaper or doing a gentle physical therapy stretch.
That is horrifying.
This is why comprehensive care demands regular DEXA scans to monitor bone density and aggressive vitamin D and calcium supplementation overseen by an endocrinologist.
Let's stick with endocrinology because the sources point to a growing body of evidence that PURA syndrome severely disrupts the anterior pituitary gland.
The pituitary is the master control gland sitting at the base of the brain. It directs the thyroid, the adrenal glands, and the gonads.
If the master gland misfires due to missing Pur-alpha protein, the entire downstream hormone cascade goes haywire.
The most visible manifestation of this is altered puberty.
How does that present?
The hypothalamus-pituitary-gonadal axis loses its timing. We see documented cases of precocious puberty, where a child's body begins transitioning into an adult physically at 7 or 8 years old.
7 or 8, wow.
And we also see significantly delayed puberty.
Imagine trying to manage the severe sensory processing issues of a nonverbal child while their body is suddenly flooded with early chaotic hormonal surges.
It is a behavioral nightmare for the parents. It requires a pediatric endocrinologist to intervene with monthly hormone injections to chemically suppress the early puberty and hit pause until the appropriate chronological age.
We also need to touch on ophthalmology. Vision issues are rampant. Strabismus, where the eyes cross or wander independently, is very common due to the low muscle tone of the extraocular muscles.
They also have severe refractive errors, like extreme myopia, requiring heavy prescription glasses.
But this isn't just about reading a book. If a nonverbal child relies entirely on an eye gaze AAC tablet to communicate with the world, their vision must be flawlessly corrected.
Exactly.
If their eyes aren't tracking together, or if they can't focus on the screen, the camera can't read their pupils, they lose their voice. Treating the eyes is treating their ability to speak.
It is entirely interconnected. You cannot silo the care. And the final major systemic issue is gastrointestinal. Chronic intractable constipation is near universal.
Again, driven by hypotonia. The smooth muscle of the intestines lacks the peristaltic strength to push waste through the system.
It creates massive, painful impactions. Because the bowel lacks the muscular strength to move things along, you have to change the physics of the waste itself. This requires daily administration of osmotic laxatives.
Osmotic laxatives work like a sponge, right?
Exactly. They contain large molecules that the body cannot absorb. As those molecules sit in the colon, osmosis forces water from the surrounding tissues into the bowel, softening the stool and expanding the colon wall.
Which artificially triggers a bowel movement without relying on the weak intestinal muscles.
Right.
So you have a child who needs a neurologist for seizures, an orthopedist for their spine, an endocrinologist for hormones, an ophthalmologist for their eyes, and a gastroenterologist for their bowels. It is a full-time medical management job for the parents.
And the management doesn't stop at age 18. This is a critical point.
Tell me about it.
The initial cohort of patients diagnosed in 2014 are teenagers now. But thanks to expanded genetic testing, we are now identifying adults in their 30s, 40s, and 50s who have lived with undiagnosed PURA their whole lives.
Which proves that PURA syndrome does not fundamentally alter a person's life expectancy.
Provided they survive the neonatal apneas and provided complications like a massive seizure or severe aspiration pneumonia are managed, they will live a full adult lifespan.
But they will remain entirely dependent. They require 24/7 care for all activities of daily living, feeding, toileting, mobility for their entire lives. The transition planning is a monumental stressor for families.
The clinical guidelines advise starting transition planning by age 12.
Wow, that early.
You have to navigate the legal labyrinth of adult guardianship, transfer complex care from pediatric hospitals to adult specialists who rarely understand rare genetic syndromes.
And secure funding for adult day programs or assisted living for when the parents physically age out of being able to lift a 30-year-old adult.
You also have to prepare for behavioral shifts. While these patients are known for their sweet, affectionate dispositions, the teenage and adult years bring new psychological pressures. Anxiety is profound, usually triggered by sensory overload or minute changes to their strict routines.
And the sources document instances of self-injury in older patients, which is heart-wrenching. But if you think about the mechanics of it, if you are a 25-year-old adult, you have adult physical strength.
Yes.
You are experiencing intense internal pain from a dislocated hip or severe anxiety, but your expressive language is still locked away.
The energy of that panic has to vent. If you can't speak it, you act it. Self-harm, aggression, or screaming emerges purely from that trapped, visceral frustration.
Which brings us full circle back to the absolute non-negotiable necessity of maintaining robust, accessible AAC communication strategies into adulthood and prioritizing sensory regulation environments.
This exhaustive, lifelong journey is why the support networks are the literal lifeline for these families. The clinical sources heavily emphasize the role of the PURA Syndrome Foundation.
The foundation is so much more than just a Facebook support group. They are a highly sophisticated advocacy organization that is actively driving the global science forward.
They recognize the holistic toll of the disease. They run structured support programs like Grand POPS for the grandparents, who are navigating the unique grief of watching their own child struggle to raise a medically fragile grandchild.
They have dedicated sibling outreach to support the brothers and sisters who grow up in the shadow of relentless medical crises.
But the most powerful mechanism they have built is the bridge between patient advocacy and hard molecular science. The foundation manages the Global Patient Registry and the Global Biobank.
This is how rare disease research actually happens. The foundation organizes families to submit their child's longitudinal clinical data.
And more importantly, they coordinate families to donate actual physical tissue blood samples and skin biopsies to a centralized biobank.
Why are skin biopsies from a kid in Ohio so important to a researcher in Australia?
Because you cannot cure a disease, you cannot study, and you cannot study an ultra-rare disease if you don't have human cells to test.
Right.
A researcher can take those skin cells, reprogram them in a lab to become stem cells, and then coax those stem cells into becoming living human neurons that actually carry the PURA mutation. They create a disease in a dish.
It's astounding. It means that the push for these registries isn't just about community building.
Not at all.
The parents who take the time to fill out exhausting surveys and hold their child's hand during a skin biopsy, they are providing the literal biological fuel for the research pipeline. The parents are the engine of the science.
Without their data, the laboratories sit empty. But with their data, the science has exploded. Which leads us to the final, most hopeful phase of our discussion, the 2026 research pipeline.
We are looking at the cutting-edge therapies in development right now, and the progress is breathtaking. But to understand the progress, we have to understand the bottleneck. You can't just invent a custom gene therapy and test it on a human toddler.
You need a proxy. You need an animal model to prove the drug is safe and effective. But standard mice don't naturally get PURA syndrome.
So you have to build one.
Yeah.
In May 2025, there was a landmark announcement that broke the bottleneck.
The Jackson Laboratory JX, one of the premier genetics labs on Earth, partnered with a nonprofit called Jack's Tomorrow.
And using CRISPR-Cas9 gene editing technology, they created a reliable knockout mouse model for PURA syndrome.
CRISPR is a molecular scalpel. The scientists at JX were able to go into a mouse embryo and precisely slice out a targeted portion of one of the mouse's PURA alleles.
They replicated the exact human haploinsufficiency, and the resulting mice exhibit the foundational features of the human syndrome: the severe motor deficits, the hypotonia, the epilepsy.
It sounds grim for the mice, but for the researchers, it is the holy grail. Because now, scientists at institutions like the Florey Institute in Australia, led by Professor Chris Reed, finally have a living mammalian system to study.
They can map the exact molecular pathways that trigger the drug-resistant epilepsy. They can take thousands of existing FDA-approved drugs for other diseases and test them on the mice to see if any of them accidentally improve the PURA symptoms. A rapid process called drug repurposing.
But the true endgame of the 2026 pipeline isn't just repurposing old drugs. It is targeted, custom biological therapies. The sources detail active studies into something called gene overexpression.
Let's revisit the haploinsufficiency mechanics. The patient has one broken copy of the gene producing useless delivery drivers and one perfectly healthy copy producing normal drivers. But the healthy copy is only doing 50% of the required work.
Gene overexpression asks a radical question. What if we ignore the broken copy entirely? What if we just leave it alone, but we chemically stimulate the healthy copy to work double time?
Exactly. If we go back to our delivery fleet analogy, half the drivers have broken hands and can't work. Instead of trying to surgically fix millions of broken hands, gene overexpression is like giving the remaining healthy drivers wider delivery trucks and double the caffeine. You push them to do the work of the entire fleet.
If researchers can use targeted RNA drugs to upregulate, to overexpress that healthy allele, they could potentially restore the total level of Pur-alpha protein in the brain back to 100%. If done early enough, you could theoretically prevent the neurological storms from ever starting.
It is elegant targeted medicine, but historically, inventing a custom gene therapy for a disease that affects only 700 people globally hits a massive regulatory brick wall.
The FDA.
Yes. To get a new drug approved, the FDA traditionally requires phase 3 clinical trials. These are massive, randomized, double-blind studies involving thousands of patients to prove statistical efficacy.
But that is mathematically impossible for PURA syndrome. There aren't enough diagnosed patients on the entire planet to fill a phase 3 control group. This rigid regulatory hurdle has killed countless promising rare disease treatments in the past. Pharmaceutical companies simply won't invest if the FDA won't approve it.
But in February 2026, the landscape shifted dramatically. The FDA issued updated draft guidance specifically targeting ultra-rare diseases, completely changing the rules of the game.
The sources note this policy shift allows a quicker path to approval based on a plausible mechanism.
What does plausible mechanism actually mean in the real world?
It means the FDA is finally acknowledging the math. They are saying, if scientists can prove in the laboratory, using those CRISPR mice and the human neurons grown from the biobank skin biopsies, that the genetic defect exists, and that their custom RNA drug directly corrects that specific molecular defect safely in the dish, the FDA may approve the drug based on that evidence alone.
They will bypass the massive human trials.
Yes, they are accepting that proving the mechanism works perfectly in a validated lab model is plausible enough to warrant giving this life-saving therapy to desperate patients who have no other options.
That is a seismic shift in medical regulation. It means customized RNA-based therapies are no longer a distant theoretical sci-fi concept. The actual regulatory roadmap from a genetic diagnosis to a targeted, individualized treatment is actively being paved right now.
For the parents listening, it means the science is moving out of the theoretical discovery phase and into aggressive preclinical validation. The tools exist, the regulatory pathways are adapting. Hope is a tangible, measurable thing in 2026.
So let's pull all of this together. We started with what used to be a terrifying, completely unexplained clinical presentation in the NICU. A floppy newborn forgetting to breathe, a medical mystery that left doctors shrugging their shoulders.
We traced that mystery to a single missing exon on chromosome 5. We looked at how a tiny typo, like P233 destroys the beta sheet structure of the Pur-alpha protein, mangling its hands so it can no longer deliver vital mRNA blueprints to the growing synapses in the brain.
We walk through the intense, exhausting daily reality of the families, advocating for anesthesia protocols, managing G-tubes, hunting for the right mix of epilepsy medications while avoiding sedating them for a startle response, monitoring spinal curves, and unlocking their child's brilliant, trapped mind using eye gaze communication devices.
And we arrived in a truly hopeful era, an era of CRISPR mouse models, gene overexpression therapies, and accelerated FDA pathways. And none of it would exist without the relentless resilience of the families who donate their data and their time to the foundation.
We hope that this deep dive has given you the foundational knowledge you need. The next time you are on the phone with a relative and you feel that wave of exhaustion at having to explain it all again, remember that you don't have to explain beta sheets or 5Q 31.3. You just have to know it yourself. That knowledge gives you the confidence to simply say, the cellular delivery system that builds the brain is broken, but we know exactly what it is, and the greatest scientists in the world are working on a way to fix it.
You are the expert now.
Before we sign off, I asked the research team to pull one final provocative thought from our clinical sources, something for you to mull over. We've spent this entire time talking about PURA syndrome as an ultra-rare disease affecting maybe 1 in a million people. But the impact of curing it might actually be universal.
This is deeply fascinating. Advanced molecular studies show that the Pur-alpha protein doesn't exist in a vacuum. It interacts with expanded genetic repeats found in 2 other major, very famous genes, C9orf72 and FMR1.
Remind us why those 2 genes are famous.
Because mutations in C9orf72 are the single most common genetic cause of ALS, Lou Gehrig's disease, and frontotemporal dementia. And the FMR1 gene is the sole cause of Fragile X syndrome, the most common inherited cause of intellectual disability.
So this little delivery driver protein, Pur-alpha, is intimately physically entangled in the cellular mechanics of some of the most devastating, common neurodegenerative diseases of our time.
It raises an incredible paradigm-shifting question. Could it be that studying this ultra-rare condition, PURA syndrome, actually holds the hidden molecular key to decoding the pathology of ALS and dementia? If we figure out exactly how Pur-alpha regulates those genes in a PRA patient, we might unlock the mechanism of ALS.
By fighting to cure PURA syndrome, these 700 families and their researchers aren't just trying to save their own children. They might just be pioneering a medical revolution that will eventually save millions of lives across the globe.
The micro unlocks the macro.
At the start of this deep dive, we talked about the diagnostic muddy waters of neurodevelopment. But look at what these families and these scientists have accomplished in just a single decade. They haven't just cleared the muddy water, they have built a microscope powerful enough to see the very bottom of it. And what they found down there isn't just an answer for PURA syndrome, it might be an answer for all of us.